Hello students, we have discussed about Sommerfeld atom model. That Sommerfeld has modified Bohr's atom model by considering elliptical orbits instead of circular orbits, and he also proposed one more quantum number along with principal quantum number, that is azimuthal quantum number, which corresponds to each orbital of the electron in a particular shell, n5. And he also proposed that because it is an ellipse, the velocity of the electron along the orbit will be very much different, and corresponding to that, the velocity will be very much closer to the velocity of light in vacuum, and hence there will be a variation in mass of the electron. Relativistic variation will be felt, and hence an ellipse will not be a fixed one as shown in the red ellipse, but it would be a precessing ellipse as shown using blue lines, blue orbits. Okay, so corresponding to that, the total energy of the system will consist of, the first part is given by the normal energy term as given by Bohr, and he has added one more term to the energy due to the elliptical nature and the precessing nature of the ellipse, and a new constant was introduced which is called fine structure constant, which is alpha, which is given by E square by 2 epsilon 0 Ch, which is approximately 1 by 137. So as I mentioned, the first part of the energy term is what is given by Bohr as energy of the electron in a particular orbit n, while the second part is given by Sommerfeld, and it is a relativistic correction given to the Bohr's energy for the electron. And it is seen that this part includes one more quantum number, which is n5, and you know from the discussion on the Sommerfeld atom model that for a given value of n, there would be 1, 2, 3, etc. up to n values of n5. These are the allowed n values for the azimuthal quantum number. So corresponding to each value of n5, there will be energy level, and hence you can mention for each orbit it will be getting splitted up into different energy levels corresponding to the n allowed values of n5. Okay, so considering this, we can explain the fine structure of H alpha line. What do you mean by fine structure of H alpha line? That is, H alpha line is seen to split up into many number of lines. So if you check H alpha is a, what is H alpha line? It is a spectral line obtained in the Balmer series, which is due to the transition of electron from n equal to 3, that is third orbit, to the second orbit of the hydrogen atom. And according to Sommerfeld theory, for any principal quantum number n, there would be n number of n5 values. So let us check. For n equal to 3, the azimuthal quantum number n5 would be 1, 2, 3, that's it, 3 number. So corresponding to that, instead of a single orbit, now you have 3 energy levels, one for 3, 1, the other for 3, 2, that is 3, 1, then 3, 2, then 3, suffix 3 for n5. Different values of n5 for the same orbit 3. Okay. Similarly, for n equal to 2, you have allowed values for azimuthal quantum number n5 as 1 and 2. So for the second orbit, you have 2 n5 values, and hence the energy level will split up into 2, 2, 1 and 2, 2. So there are 3 energy levels in the third orbit and 2 energy levels in the second orbit. So we have how many possibilities of transitions? We expect 3 into 2, that is, we expect theoretically 6 transitions would be possible, that is from upper orbit to the second upper orbital in the second orbit, Then you have upper orbital to the lowest orbital in the second orbit, and other is 3 2 2 2 2. Similarly 3 2 to 2 1. Next possibility is 3 1 to 2 2 and 3 1 to 2 1. So these are the 6 allowed possibilities for a transition from third orbit to the second orbit as seen in the H alpha. So we expect that 6 splitted lines, spectral lines will be obtained for H alpha. But experimentally it is seen that there are only 3 components observed in H alpha spectral line. So hence Sommerfeld applied some selection rule to match the experimental observation with the theoretical one, and hence he proposed the selection rule as n phi can those transitions are allowed for which the change in n phi is given by either plus or minus. That is, a transition can happen from a consecutive n phi alone. So let us check which are they. So which are the possible? From 3 3 to 2 2. Here you can see 3 and 2. So the difference is plus 1. Okay, and the next possibility, let us check 3 3 to 2 1. Is it possible? Is it possible? No, because you have 3 and 1. 3 and 1. So that will be plus 2. So that is not allowed. And the next one is 3 2 to 2 2, which means you have same value for n phi. So the variation will be 0. So that is not allowed. And next possibility is 3 2 to 2 1. That is allowed. 2 minus 1, and hence it is allowed. So this is okay. This is also okay. And what about this one? 3 1 to 2 2. So 1 minus 2. So what is it? Minus 1. So that is okay. And the other one is 3 1 to 2 1. Again 1 and 1 in as n phi. So the variation is 0. So that is not allowed. So which are the allowed transitions? Which are the allowed transitions? 3 3 to 2 2. Therefore delta phi equal to minus 1. Then 3 2 to 2 1. The delta n phi, variation n phi is again minus 1, and 3 1 to 2 2. So the delta variation in n phi will be plus 1. Okay. So those are the only 3 allowed component, and hence it matches with the experimental value. But so we think that it was successful in explaining the hydrogen spectrum, H alpha splitting in hydrogen spectrum, or you can mention it as fine structure of H alpha in hydrogen atom. But there were many number of failures involved, because it was partly successful, and it was difficult to explain spectrum of higher atoms, and it could not explain the actual number of components in for a higher spectrum, and also what would be the intensity of each line. That also could not be explained using Sommerfeld atom model. So that ends the Sommerfeld atom model. Thank you.